Okay, let's see a little bit more of what they have to say. I'm kind of new to these slides, so that's why I'm a little um, herky-jerky with it about what's going on here. So anyway, all right, so we set up a coordinate axis system, basically is what they're saying. All right, and we're doing one-dimensional motion. What do I mean by one-dimensional motion? Everything's going to be going on a straight line, okay? Everything we're going to be doing, and why am I clicking all over the place? I have no idea. All right, so everything we're going to be doing, I wanted to show you this, is we're one-dimensional for chapter 2. One-dimensional motion for chapter 2, okay? We're just going to be going in a straight line. All right. So let's take a look at some of their slides here. All right. Which are, they're okay. They've got a lot of, but you may or may not know it. So it's convenient to have an X and Y coordinate axis system. Now in chapter 3, we're going to be going projectile motion. Like when you hit a home run, it's going to have an X component and a Y component. All right. It's not going to be that hard though. You're going to be great. All right. So the motion of these racing snails. We would say these guys are actually, since we could rotate this picture and have them be going in a straight line, but their speeds and their velocities, so if they're going in, you can take their position divided by their time, gives you their total distance covered divided by their total time. That gives you their average speed. Okay. The displacement divided by the total time is equal to the average velocity. Okay. All right. So the displacement. So more detailed record of that passenger. All right. So he's here. I mean, this is where you're looking on the plane, but then I'd say this is where he is. He goes back a certain distance, goes even back further, all the way to the back. He might have came back a little bit this way, then he went back that way. So his total distance is from here to here. He might have stumbled all over the place, is what they're saying. I thought they were showing this plane moving, right? So he got up. The cart lady was in the way, so he scooted over, went a little bit further. Oh, another cart lady's coming, so he's got to go back. So he went back. So we just had the total, just his total displacement. This is his total displacement. All of these added together, absolute value-wise, gives him his total distance, though. All right, so here we go. During a 30-minute trip, now this is crucial. 30-minute trip to the store. The total distance traveled is 6 kilometers. All right, so it took 3 kilometers to get to the 3 kilometers. 3,000 meters to get to the store, 3,000 meters to come back. So the total distance you went, 6 kilometers. The average speed that you went, because was 12 kilometers per hour. So you covered 12 kilometers per hour, then the time that you were gone was a half an hour, right? Okay, so the average speed for the trip was 12 kilometers per hour, all right? And then the time was 30 minutes, right? So 6 kilometers, the average speed is 6 divided by 0.5, which is the hours in the thing. And then, so that's 12. But the average velocity is 0 because your total displacement is 0. So you take 0 divided by the 30 minutes and it comes out to be 0. All right, so let's look at the position versus time graph. Here's the position. Here's the position versus time graph right here. Boom, boom. All right. Okay. So the velocity for the first part of the trip was positive 12 kilometers per hour. The velocity for the second part of the trip was negative 12 kilometers per hour. So you add the two velocities for the entire trip, you get 0. Okay? And then the speed versus time graph, you want a total of 12 kilometers, well, at 12 kilometers per hour, okay? And it just stayed there at 12 kilometers per hour the entire trip, okay? That's the average speed, all right? Okay, now we get into acceleration, all right? Get into acceleration. So this is a good time to pause, stop here, and we'll talk about acceleration.